Okay, this is question 2004B, question 3. I will not be reading the question to speed things up. So, if the filling equipment is functioning properly, what is the probability that the weight of the ore in a randomly selected car will be 70.7 tons or more? I see the word probability and I immediately go, gosh, I need to know whether or not what type of distribution I'm working with. So I go back and reread this and I go, okay, reading along, and it says, oh, they're normally distributed. Okay, so I'm working with a normal curve with a mean of 70 and a standard deviation of 0.9. So if I'm drawing a picture of this, just a very, very basic picture, my mean is at 70, my standard deviation is at 0.9. Now, they want to know the probability it'll be 70.7 tons or more. So this value right here is X, is 70.7, and I'm looking for the area right here that's shaded. Please remember a normal curve goes off to positive infinity in this direction, and they are telling me more, so I know it's being shaded to the right. Now, anytime they tell me normal curve, I write down Z equals X minus mu over sigma and start trying to figure out what I have and start plugging in. So I have the probability that Z is greater than or equal to 70.7 minus my mean was 70 divided by my standard deviation of 0.9. I do not have to worry about the distribution of the means because we're only talking about a car. So only talking about one, so only dividing by this standard deviation of 0.9. So really important that we go ahead and calculate our Z-score. And so 70.7 minus 70 divided by 0.9, that quantity divided by 0.9 is 0.778. So I want the probability that Z is greater than or equal to 77.78. Well, I'm just going to go to use my calculator to do a second VARS. Second VARS, normal CDF. My lower is 70.7. My upper is 99 all the way to infinity. My mean is 70. My standard deviation is 0.9. Press enter a couple times, and I find out that that probability equals 0.2183. The next part of that question, part B, says, suppose that the weight of the ore car in a randomly selected car is 70.7 tons. Would that fact make you suspect the loading machine is overfilling the cars? Well, what they're asking is this rare? Is this unusual? In AP statistics, we define rare as less than 5%. Well, we're at 21.8%, so we would say, no, this is not particularly rare. So no, this would not lead me to suspect. So no, this would not lead me to suspect that the ore cars were being overfilled. I would expect this to happen 21.8% of the time, and that's what I would write out. So no, a weight of 70.7 for a single car would occur about 21.8% of the time if the machine is loading properly. Okay, part C. If the filling equipment is functioning properly, what's the probability a random sample of 10 cars would have a mean ore weight of 70.7 tons or more? Well, this is, now we're talking about the mean. Consequently, we're still working with a normal, so our picture is still going to be the same. This is still going to be centered at 70. We're still concerned about 70.7. But now we're talking about the mean, and because we're talking about the mean, I know I'm going to have to work with central limit. So x bar minus mu over sigma divided by the square root of n. And what I'm looking for is the probability that x bar is greater than or equal to 70.7. So once again, I'm just going to start by plugging in what I know. So I have the probability that z is greater than or equal to 70.7 minus 70 over, now my standard deviation is 0.9 divided by the square root of n, and n happened to be 10. So 0.9 divided by the square root of 10. I'm going to go back to my calculator and plug that in. Second vars, normal, CDF, 70.7, which I already have in there, 99999 to represent infinity, mean is 70, standard deviation of 0.9 divided by the square root of 10. And I just raise it to 10 to the half power, which is the same. When I do that, I end up getting a value of 0.00, I'm going to 69, but I'm going to go ahead and round it to 0.007. That's less than 1% of the time. So that's pretty rare. So based on my answer in part C, if a random sample of 10 cars had a mean ore weight of 70.7, would you expect that the loading mechanism was overfilling the cars? Justify your answer. Well, in this case, 0.007 is less than 5%, so 0.007 is less than 0.05, and that's my standard that I like to use, and I think is a good standard for AP statistics. So yes, this would be very uncommon to occur if the machine were loading correctly. There is less than a 1% chance that this could happen. I believe the machine is overfilling. Thank you.